Hey there, Algebra 2. Welcome back to another episode of Notes, Lesson 24. Our objective learning target today is to learn a third way to solve system of equations. If you remember, we started with graphing in Lesson 15, and then we looked at substitution in Lesson 21. Today, we are going to learn the third method, which is elimination. The elimination method is where we eliminate or cancel a variable by adding or subtracting the two equations together. And one thing to note is that the two equations will need to be in standard form. And the most common variables we use are x and y, so the equations need to be ax plus by equals c. So we're going to have our x and our y on the same side of the equation equal to our constant c. So example one, we're going to solve the system and then we're going to classify the system. First thing I'm going to do is I'm going to rewrite both equations in standard form. On the top equation, I'm going to add 4y to the left side with the x. Once I do that, my equation will look like that, which x and y are both on the same side of the equal sign. On my second equation, I'm going to subtract the x over to the left side, which will make my equation look like that. Now I've got everything lined up vertically, like if we were adding or adding numbers together or something like that. I've got my x column, I've got my y column, and then I've got my constant column. So here's where we can add or subtract the two equations together because these equations are working together and the properties of equality let us add or subtract them. We are going to try to eliminate one of the variables. So what you're looking for is like in this case, two variables that have the exact same coefficient. So 4 and 4, if I subtract 4 minus 4, that makes 0, which is going to cancel out my y variable. So my whole second equation, I am going to subtract, and then I'm going to collect all my new terms below. When subtracting, you got to follow the integer rules of subtracting. So first I'm going to go 2 minus negative 1. When we subtract a negative, that's equal to a positive. So that's going to be 3x. Next, I'll take my y column, 4 minus 4, which is going to be 0y. So you can decide to write out 0y, or you can just leave that blank. And then lastly, I'm going to go 2 minus a negative 7, which is going to give me 9. So remember, minus a negative, you're adding. Now I've got 3x is equivalent to 9. So 3 times some number equals 9. That's going to mean my x is equal to 3. Once we know x is 3, now we can use 3 back into one of these equations to solve for y. So I'll go and substitute 3 in for x. So I'll substitute x in for the equation, and I'll do my algebra. So 6 plus 4y equals 2, which will give me 4y equals negative 4. Once I subtract that 6 over, y is negative 1. Now I write my answer as an ordered pair because remember from graphing, and we talked about it in substitution, this is an xy coordinate where your two lines cross, 3, negative 1. When we have one solution, that would be classified as independent. So we'll set up our two equations in standard form again. So again, I got x and y collected on the same side. So 9x plus 8y equals negative 7. And then I subtracted the 9x over, so I get negative 9x plus 18y equals 45. And I just like to have the x and y on the left and then the constant on the right. So here I'll look again for two of my variables that are the exact same number. So 9 and negative 9. Now to make those 0, I'm going to add these two systems together. So 9 plus negative 9 is going to give me 0x. 8 plus 18 is going to give me 26y. And then negative 7 plus negative 45 is negative 52. Now we can get our y solved out. Y is going to equal negative 2. Once I know y is negative 2, I'll use negative 2 in one of my two equations. I'll just use the top equation. So we'll get 9x plus 8 times negative 2 equals negative 7. And then I'll continue to solve that out, and I'm going to put my answer over here. We'll get x is 1, y is negative 2, and that would be an independent system. So in both cases, we had to locate the variable that had the exact same coefficient so that we could either add or subtract to cancel that variable out. But elimination is a nice method to quickly solve for one of your variables, and then you're going back to using substitution to find the other variable. Next, we'll just take a look at solving some systems that involve some fractions and then some other things using elimination. So the big thing with fractions is if you ever have a fraction, you can multiply your whole equation by the denominator of that fraction, or we'll find this later, if you have two different denominators, you're going to multiply it by the least common multiple. So I'm going to multiply this by 3. 2/3 of 3 is going to be 2, so I'm going to have 2x equals 4y. And then we're going to get that set up so that we have it in standard form. So that's going to be 2x minus 4y equals 0. And then our second equation is already set up in standard form. We're going to have 2x minus 3y equals 9. All I did was just move the 9 to the right side. Now we're ready to look at using an elimination. So right away I can see that I have a 2x and a 2x. So I'm going to subtract these two systems so that I can get my x's eliminated. So 2x minus 2x is 0x. Negative 4 minus negative 3, that's going to be like negative 4 plus 3, which is negative 1y. And then 0 minus 9 is negative 9. So that's going to be dividing each side by negative 1. So my y is going to equal to 9. Once I know my y is 9, and silly me, I did this 3, I times it to the 2x, but I forgot to times it to the 4. So you're going to have to go back, erase, that would be a 12. That would be a 12. So we're going to get negative 9 equals, negative 9y equals negative 9, which is going to be a positive 1. So my y was not 9. It should have been a positive 1. Now, once I know that my y is 1, now I can start to use one of my two equations to find the x. So we've got 2x equals 12y. Well, I could substitute that 1 in for my y. So I'm going to end up getting 2x equals 12 times 1, which is 2x equals 12, which is x equals 6. So there's my two solutions, and put that over here, x equals 6, y equals 1. There'd be my two answers. Taking a look at B, we've got some more fractions, so we're going to clear the fractions. So if I take and multiply by the least common multiple of 4 and 3, then I can clear those fractions. So the least common multiple between 4 and 3 is 12. So 3/4 of 12 is going to be 9. So I'm going to have 9x. And then this is y divided by 3, or 1/3 y. 1/3 of 12 is going to be 4. So 4y. And don't forget to multiply everything, like I messed it up here, but now we're going to take 12 times 10, which is 120. Down below, I have a denominator of 2 in my fraction, so I'm going to multiply everything by 2. Half of 2 is going to be 1, so that's going to be x plus 10y equals 64 times 2 is going to be 128. Now here's our first case where we do not have any of our variables that are the exact same coefficients. So we have to manipulate one of our equations to get those coefficients the same. So what I like to do is this 9 right here, and I just have a 1x. If I could make this x a negative 9, then I would be able to do 9 and negative 9 to cancel that out. So I'm going to take this equation, we're going to multiply everything by negative 9. And then we'll rewrite our system over here. So we'll have our 9x plus 4y equals 120, and then we're going to multiply negative 9 through everything. Now we're ready to add. So we're going to have negative 9 plus 9 is going to be 0. 4 plus 90 is going to be 94y. And then 120 plus 1,152 is going to be 1,272. Now we'll divide by 1,272 to get our, divide 94 into 1,272 to get our answer. So looking at the negative 9, we multiplied to each. This should have been negative 90, negative 1152, which will give us 86 equals, 86y, excuse me, negative 86y equals negative 1,032. And then we divide by negative 86, we're going to get y is equal to 12. And then same as before, we'll take our y is 12 and we'll put that into one of our equations. So using this one, this would be probably the best one to use, x plus 10y equals 128, and we'll solve for x. Once we solve for x, we will get 8. So 8, 12 would be our solution. So that wraps up day 1 of lesson 24. Tomorrow will look more like this example 2 part B, where we'll have to manipulate our equations a little bit, but you are now ready for your practice, and you can go ahead and good luck, and we'll see you next time.